This lesson is about a special factoring technique called difference of squares. The formula is x squared minus y squared equals x minus y times x plus y. Let's review some definitions. When you square a number, you multiply it by itself. For instance, 5 squared is really 5 times 5, and x squared is really x times x. You should definitely try to memorize the first 20 square numbers. Try practicing them when you're standing in line or driving through traffic. You should be able to recite 0, 1, 4, 9, 16, 25, 36, 49, 64, 81, 100, 121, 144, 169, 196, 225, 256, 289, 324, 361, 400. The more familiar you become with these numbers, the easier these types of math problems will become. Another useful definition is the power rule for exponents, such as x to the power of m raised to the power of n is really x to the power of m times n, such as x squared to the 5th is really x to the 10th, because 2 times 5 is 10. Another useful definition is a conjugate pair. A conjugate pair of binomials are two binomials with the same terms but opposite signs, such as x minus y and x plus y. When you multiply a conjugate pair of binomials, there is a special result. Namely, notice with FOIL, first x squared, outer x times y, inner x times y, but this time it's negative, and last, negative y times positive y is negative y squared, and what you notice is the middle two terms cancel out, and you're left with x squared minus y squared. This result is the difference, otherwise subtraction, of two square numbers. We call this relationship the difference of squares. Usually we use this relationship in the reverse order. X squared minus y squared is equal to x minus y times x plus y. Here are some examples. A squared minus b squared is a minus b times a plus b. Or 9 squared minus 7 squared is 9 minus 7 times 9 plus 7. You can use this result to more quickly calculate a difference of squares. For instance, 9 squared minus 7 squared is 81 minus 49, and that result is 32. Without doing that calculation, instead you could have done 9 minus 7 is 2, and 9 plus 7 is 16, and sure enough, 2 times 16 is also 32. So it's just a different way to calculate numbers. Here are some more examples. And keep in mind, it is helpful to rewrite a square number in exponential form, such as write 81 equals 9 squared, or 25x squared as parenthesis 5x squared. So let's consider more examples. 81 minus 49 is really 9 squared minus 7 squared, and you can use the difference of squares rule. X squared minus 36, rewrite it as x squared minus 6 squared, and then use the difference of squares rule. 16x squared minus 25, you can rewrite the 16x squared as 4x quantity squared, and the 25 as 5 squared, so that you can use the difference of squares rule. In this example, 121x squared can be rewritten as 11x squared, and 64y squared can be rewritten as 8y squared, so that you can use the difference of squares rule. Here, x to the 4th minus y to the 6th, notice that x to the 4th can be rewritten as x squared squared, and y to the 6th can be rewritten as y cubed squared. And that way you have two square numbers being subtracted, and you can use the difference of squares rule. Here are some practice problems for you to do. When you're done, go to the next screen and you can check out the answer key.